Hello, my name is Priyank Desai. I am the Senior Solutions Engineer here at Couchbase. In this video, I will cover Couchbase cluster architecture, different services that we have offer in our data platform, and also how the data flow works within the cluster, and also outside the cluster if the data need to be replicated to any downstream system. So let's go ahead and get started. We'll get started with this gray box here in the middle, which represents the Couchbase cluster. So the first service that we have in Couchbase is called the data service. So also known as a key value service. So all your data that you write in Couchbase, they get stored on the nodes running the data service, and the fastest way to access data on these nodes is via key value operation. So where the application or the client, they provide the key, and the Couchbase will provide back the document. This is the fastest way to access the data in Couchbase. So if your application requires super fast performance in a millisecond or sub-millisecond, key value operation is the way to go. We also have caching layer built in to our product. So all the frequently accessed data, they get maintained in the memory, and anything that are not recently used documents that are evicted from the memory to make room for the new one that's coming in. So depending on the memory that you have allocated for the given bucket, we maintain that much data in the memory all the time. As you can see in this diagram, we also have persistent layer available as well. So persistence capability is available as well. So your data is not only stored in memory, but it also is available on the disk. And again, depending on how much memory you have allocated, entire data set could be feeding in the memory, or some could be in memory, and the other can be on the disk. So that's that. So this is one way to access the data in Couchbase, that is via key value operation. But what if your application cannot run key value operations and has to perform some kind of secondary lookup? To support that access pattern, we have this query service available. Our query service is called SQL++. SQL++ basically is a SQL for JSON. So anybody who is coming from a SQL background, they can use their existing skill and and expertise and use it in Couchbase. So all the joins, the way it works in relational database, all those joins, the inner joins, outer joins, common table expressions, they all work the same way in Couchbase as well. So the point here is that if you have worked on relational database and you want to work on Couchbase, there is not much learning curve, and you can get up to speed with Couchbase in a matter of couple of hours. So the benefit is this, for our SQL++ languages, you can take advantage of power of SQL, and also take advantage of flexibility of the JSON schema, where you can add and drop attributes on the fly in your data. So just and then to support the query service and to speed up the query, we also have support for indexing capability as well, for the to create secondary indexes. So just like how you create index in the relational database world on a column or a combination of column to speed up the query, the same concept is applicable in Couchbase as well. So depending on how the query looks like on your depending on the where clause, you create an index on an attribute or a combination of attribute, and that can speed your query and perform the lookup very fast. The other benefit of indexing is whether when you run query using the indexes, it does not have to perform the entire bucket scan, and instead it can go after the index documents and perform lookup faster. As you can see on the index node as well, we have persistent storage available. So there are two forms of storage available for indexing service. Now one is memory optimized storage, which is called memory optimized indexes. The requirement for MOI is your entire index has to fit in the memory, or else the index can become stale, and because it runs out of memory. If you do not want to allocate enough memory, you can also use our standard GSI, also known as a plasma index, where the index can spill over to the disk if there is not memory available to fit the entire index. So there are different storage options available for indexing requirement, and depending on your SLA requirements. Coming back to the query service, you can see this green arrows going, from data service, from index service, from the full text search, and so on. So anytime the client submits a query against the Couchbase cluster, query service is the word service who determines, who parses the query and determines if there is any supporting index available. And if there is an index available, it makes use of that index, get the necessary attributes that the query is asking for, and send it back to the client. So that's a straightforward, lookup from the index node, which is also which you can also call as a covering index, because all the attributes that the query is asking for, it is available in the index itself. Now, what if there is no covering index, meaning you are running your query is asking for all the attributes, and there are no index available that has all the attributes that the query is asking for. In that case, what the query service does is, it goes to the data node as well. We remember, which has the entire JSON document available on the data node. So query service will go to the data node and get those additional attributes that the query service is asking for, and then collect those attributes and send it back to the client. So different ways to access the data. Now, it is also possible that a query service is making use of our search function in the where clause. So in that case, what the query services will do is, it will make a trip instead of the data service. It will call the full text search. It will make use of the full text search index, get the documents that the query is asking for, and then send it back to the client. So again, depending on how the query is written, it is capable of using the index, if it is a covering index, and provide the data back to the client. Or if it needs to go to the data service, it will go to the data service and provide the data back to the client. And if there is a search function that is being used in the search in the SQL++ query, it will go and call this full text search service as well, and get the necessary data and provide back to the client. So just like the indexing service, we also have support for full text search. So if your application requires search capability, you now no longer require a search or Solar or another search solution to support your search requirement. And that not only eliminates an additional technology in your tech stack, but also it simplifies your architecture and also brings your total cost of ownership down, because you are dealing with one software compared to two software. So how do we make sure that when the data get created, updated, and deleted on the data nodes, how do we make sure that the associated the global secondary indexes which supports the SQL++ query or the full text search indexes are kept up to date? So to do that, we use something called a DCB protocol, so database change protocol. That's our secret sauce, and that's the streaming protocol that we use to move the data around within the Couchbase cluster. So anytime any document gets updated, created, or deleted, we have to make sure that those mutations are applied to the index node, to make sure that the associated indexes are up to date. We also have to apply the same mutations to the full text search nodes to make sure that the full text search indexes are kept up to date as well. So, and that is all being done with the DCB protocol, which is the streaming protocol. And to make it simpler, in the GSI service, the full text search, they are just a subscriber of this DCB stream. So as the data gets created, updated, and deleted, those mutations they move and flow into the and they get applied into the secondary indexes as well as the full text search indexes. So that's the way things are kept in sync within the Couchbase cluster. So these are the services that we have. The next service that we also have available is called analytics service. So the typical analytics use case it works is that you would have an operational database and a separate instance of analytical database, and then in between there will be some kind of ETL process that will be executed overnight to extract the data from those operational, transform the data, and load it into the analytics instance of the database. What that also means is that you don't get access to the data in real time, and that means you cannot put your data to work immediately, rather than you wait for a day or so, and on top of that you deal with the ETL process. With Couchbase analytics, first of all, you get access to the data that is getting ingested, in real time, or even the data is available. It's available for querying purpose in real time. Uh, that's the benefit of analytics service in Couchbase, and you don't have to write a single line of ETL code to move the data around from data service to the analytics service. So, and again, the same mechanism is used to move the data from data service into the analytics node, which is the DCP protocol. So anytime the data gets created, updated, and deleted on the data node, all those mutations, they immediately gets applied to the node running the analytics service. You also see this little filter available on this DCP stream that is going into the analytics service. This filter is basically, is used to filter out the data. So, if you don't want your entire data set that is available on the data service to be replicated to the analytics node, you can put a filter. So, you only get those filtered data on the analytics node. And the one reason for doing that is that the reporting only needs to be done on subset of the data instead of the entire data set that is available in the cluster. So all these capabilities are available in Couchbase. The other the other benefit of our analytics service is that we also have connectors available to if there is a requirement to be able to view the data from analytics service into Power BI or Tableau. We have connectors available, so we can view the data straight from analytics service into those visualization tool. If you simply want to just query the data that is available on the analytics node, we have the analytics workbench, query workbench available. And the way to access data is, again, SQL++ language, the same language that you would use for the query service. Again, using SQL++ language is much more easier, and most of the folks are familiar. So there is not much learning curve there as well. The next service that is available within Couchbase is called eventing service. Eventing service is basically the way it works in Couchbase is it works on event condition action model. So event is nothing but a document when the document gets created, updated or deleted, or even the document get expired, those are treated as event, and when any of those event happens, the condition gets checked and the action gets taken. So and then the eventing function is written in JavaScript. So you develop the function using JavaScript, deploy it on the node running the eventing service, and you're pretty much done. Your logic stays close to the data, and as the data gets manipulated in Couchbase, created, updated, or deleted, eventing service, again, it's a subscriber of the DCP stream, so it will immediately determine that something changed, and it will act upon those change and take an action. If I were to compare eventing with the relational, you can compare with relational database as something like a post trigger, where something happens and an action gets taken. Eventing is a very powerful service in Couchbase, which can be used to also perform selective replication. So if you were to replicate data from Couchbase into some other system via Kafka, which I'm going to talk about in a second, you can do that as well. So you can put a logic in eventing function to say that if my X attribute changes, only then you replicate data and put that into Kafka queue. Otherwise, don't do it. You can do things like that. You can set alerting mechanism. You can send an alert depending on a specific attribute change or any kind of document change. So different ways you can use eventing and to solve different use cases. Next is the XDCR. XDCR stands for Cross Data Center Replication. So if there is a requirement to replicate data from one Couchbase cluster to another, you would leverage our XDCR capability, which can replicate data from one cluster to another. Or if you have more than 2 clusters, you can also use XDCR to replicate data across that many clusters that you have. You can replicate data unidirectionally, bidirectionally, or even multi-direction if you have more than 2 clusters and if you want to move data around. As you can see here, there is a filter here available as well. So there is a filtering capability available in XDCR as well. So if your requirement is such that you do not have to replicate the entire data set from one cluster to another, You can make use of this filtering capability in Couchbase. That way, you only filter the data that you need to, get replicated to the other side. The replication capability that is available via XDCR is memory-based replication. So you are operating at the speed of network. So depending on from where you want to replicate data to the destination, depending on the distance and the network speed, you can expect your data to be replicated with that much latency to the target. Next is we also have connectors available, so we can be used in conjunction with Kafka or Spark. So if you want to replicate data from Couchbase to Oracle or any downstream system, Oracle or any other relational database, or as a matter of fact the other way around, where you want to move the data from Oracle back into Couchbase, you can make use of Kafka and these connectors, and then you move the data back and forth from Couchbase to relational database, or relational database back to Couchbase. So these connectors can be very helpful to move the data around from one cluster to another. We also have backup service available in Couchbase, where you can automate the backup, you can schedule the backup, full backup, incremental backup. You can also merge backup. So traditionally, you would, if you have a large database, you would run a full backup once a week, and then incremental backup towards the middle of the week. And with Couchbase merge backup capability, you can merge the full backup and the incremental backup. So if the time comes to restore the database, you don't have to restore the full backup followed by an incremental backup, which can be very time consuming, and it can be very tedious. So with the help of merge, now you have single backup. You just restore the single backup, and you are done, and makes it very easy. As you can see here, the green arrows going to the Microsoft Azure, blob storage, and Amazon S3. So with this backup service is capable of taking the backup locally on the node running the backup service and store the backup there. Or if you want to back up your entire cluster into the low cost storage like Amazon S3 or Microsoft Azure blob storage, backup service is capable of doing that as well. Now we also see the green arrow going back from Microsoft Azure blob storage and Amazon S3 back to the analytics. What that does is it allows you, so if you have your data stored on Amazon S3 or Microsoft Azure blob storage, analytics service is capable of running the query straight onto the data that is stored on Amazon S3 or blob storage, without having to move the data back into Couchbase cluster. So that can be very powerful feature if you don't want to be moving the data around from Couchbase cluster to the Amazon S3 or Microsoft Azure blob. The other one other cool feature that is also available, and that is also Couchbase is capable, is that you can have some 50% of your data set available on Couchbase analytics node, and 50% of the data can be on Amazon S3 or Microsoft blob storage. Analytics can also run query across those two data set as well. All you do is create the external data external link to it, and then you are done. You can start querying the data between analytics service and your data available that is in Amazon S3 or Microsoft. That can be done as well. And as you can see in this diagram, we are showing full text search and several nodes for full text search, query nodes, similarly for data index and query. The point here is that for a distributed database system, you can run these services definitely on different nodes, but we also have feature where we allow you to run all these services on different nodes, but also not only run different services on different nodes, but also you can scale those services horizontally and independently depending on your workload requirement. So in other words, you can start with 3 nodes of each of the services, and if your workload, for example, for the full text search is expected to go higher in the next month or so, you can scale the cluster out, and when you scale the cluster out, you can only scale the full text search service and leave the other services as is on the number of nodes that it's running. So not only it allows you to multi-dimensional scaling capability, allows you to scale the cluster horizontally, but also it can isolate the workload. So as you can see here on the left hand side, you can your all your key value operations, the query, they can be available to support your transaction slash operational workload. And in the same cluster you can have analytics node available, eventing and other services available that can be used for ad hoc querying, so or for supporting your analytical workload. So again, one cluster can support one Couchbase cluster can support hybrid workload, which is operational transaction or OLTP slash OLAP workload. And then again, all these black arrows, they are representing the DCB protocol. So anytime anytime the data gets created, updated and deleted, the same protocol is being used to move the mutation and apply it to the to the appropriate node running the appropriate services, and so on. And come to the the last point. So all these things, capabilities are available, but how does client work with these different services in Couchbase cluster? So as you can see on the left hand side, we have these different software development kits available in different languages. And the way the client operates with Couchbase is the when you start your application, the client makes looks up the connection setting, and it goes after the first node. And as soon as the connection is established with first node in the cluster, it determines the topology of the Couchbase cluster. So in other words, the moment the first connection is established from the client, it determines how many nodes are available in the Couchbase cluster, which nodes are running the data service, which nodes are running the query service. And accordingly, when the request comes along from the application, the client is smart enough to send the request to the appropriate node running the appropriate service, which makes the lookup significantly faster within Couchbase. And again, the sharding is automated, so that is something that the client does not have to worry. So again, the moment the client gets connected, it becomes topology aware, and the client can start writing the data and fetch data from the Couchbase cluster in different access pattern that that is required for the application. So that's pretty much it for this. Thank you, and I will see you in the next section.